All right, in this video we're going to be learning about graphing sine waves. And sine waves include both sine and cosine, and they'll also be referred to as sinoids or sinusoids as well. For this example, here we're going to be looking at y equals a times sine of bx. So b is being multiplied by x, then it's going through the sine function, then being multiplied by a, all before we get y. So y equals a times sine of bx, and y equals a times cosine of bx, where a and b are not zero. And we'll get back into why they're not equal to zero at the end of this video. So for now, think back to chapter 4, where we learned about functions, and specifically periodic functions. Two characteristics that we learned about were amplitude and period. And remember, amplitude is the distance from the center of the graph to the top or the bottom. And you find it by taking the maximum height and subtracting the minimum height, and then dividing by 2. So again, it's from the wherever the center's at, and if it's up or down, that's fine. But from the center to the top, that's the amplitude, or from the center to the bottom, that's also the amplitude. And again, you find it from the maximum, taking that y value, minus the minimum, taking that y value, and dividing those by, once you've subtracted the maximum minus the minimum, divide that by 2, and that gives you your amplitude. Okay. So for a standard sine wave, the maximum height is 1, which we know from the unit circle, and likewise the minimum height is -1. If we adjust the a value here, so adjust the a value, then we change the new maximum minimum values, meaning we change the amplitude. For example, if a is 3, so if a is 3, now the new maximum is now +3, and the new minimum is now -3. And the amplitude itself is also 3, since 3, the new maximum, minus -3, the new minimum, is going to give you, so 3 minus -3 is going to give you 6, and 6 divided by 2 equals 3. So again, the maximum minus the minimum divided by 2 gives you your amplitude. And even if we'd plugged in an a value that was negative, it'd still have that same effect. It would flip it over the x-axis, or more technically reflect it over the x-axis, but it's still going to be stretching it vertically. So because of this, the amplitude is going to be, for a sine graph, is going to be the absolute value of a. Whether a is positive or negative, the amplitude is going to be the absolute value of a. All right. Now the period. The period, on the other hand, is the b value, on the other hand, affects the period. So the b value affects the period. And since b is multiplied by x, the angle, before it's put through the sine functions, sine or cosine functions, it affects how frequently the cycle repeats, which again is called the period. And remember, the period for a function is similar to something like listening to a song. If the song normally lasts, say, 10 minutes, which would be its period, if I then play that song at double the speed, or at 2 times its speed, effectively putting a 2 in as the b value, then the song is played in only half the time, or in 5 minutes, half its original length, or half its original period. So how do we show that? Well, for a standard sine or cosine wave, we've got one period is going to be equal to 2 pi, or 360 degrees if we're talking about, whether we're talking about radians or degrees. Now, if we double its play rate, double the speed of that song we're playing it, the b value, if we put 2 in there for b, that whole period, or for us, for it being 2 pi, the period, it's all going to be completed now in half that length. It's been multiplied by 2. So what's happening is that the new period is divided by b. Divided by b. So for our example here, if we put in b as 2, then what happened in 2 pi radians before now only takes pi radians at this point. Or if the b value was 3, for example, then what at one point took 360 degrees, now it only take 120 degrees. So let's go with this part first. So as a kind of as a side note, if we rewrite the functions, so y equals the sine of 2x, or y equals the sine of 2 times x, and these here are going to be essentially the same, whether the b value is inside the parentheses or outside. But this is only in terms of period. Only in terms of period. And this part should make sense. Notice that if we were to distribute the 2, we'd get 2x, or if we think about a 1 in front, we multiply it by 1, we still get just, each of these would be equal sine of 2x. So the period is going to be the same either way, because the b value is the same in any of those situations. However, if we had something where we had sine of y equals sine of, let's say, 2 times x plus, let's go with 45 degrees, that is not going to be the same thing as sine of 2x plus 45 degrees. Notice if we were to distribute that 2 in, obviously that would change the 45 degrees. However, the 2x, the b value, and just the period itself, that would be the same either way. All right, and then last part here, kind of a long video, sorry about that. It says where a and b are not 0. Let's reason through why that would be real fast. If a was 0, well then whatever sine of bx was, it's going to be multiplied by 0, and so we're just going to get y equals 0, or y equals, if there was something being added on afterwards, and that'll happen for us later, then it'd be that new constant. But if a is 0, then all that part there just kind of disappears. It's no longer important because it's being multiplied by 0. And likewise, what if b was 0? Well, remember that x is the angle, and so if the angle is immediately being multiplied by 0 and then put through the sine or cosine function, then it's always going to be, cosine's always going to be evaluating at 0, or sine's going to always evaluate at 0. And so we won't get a wave, we'll just again get a constant and just a straight line. So I hope that helps.